This video is a quick review of how to solve equations. So the goal of solving an equation is to find the one and only one value for your variable, like x, that would make this a true statement. So what we do is we look at the variable, we see what's happening to the variable. Here we have 11 being added to the variable, being added to x. So what we want to do is undo that. So we will do that by performing the inverse operation. So the inverse of adding 11 is subtracting 11. So we're going to subtract 11 and make sure you subtract it from both sides, okay? Remember, this is an equal sign. It means that the left side is equal to the right. So whatever you do to one side, you have to do the same thing to the other side so that this equality will remain true. I like to draw a line. I think it keeps your work a little bit more organized. And then what I do is cross out this 11 and 11, this positive 11 and negative 11, because those two operations, adding 11 and subtracting an 11, are inverses of each other. They cancel each other out. So then, right from left to right, what remains? We have x remaining on the left, and on the right, 63 minus 11 is 52. Now, the nice thing about solving equations is you can always be sure that you are correct, so you can go back to that original equation where you see this x. Let's replace it with our solution. We got 52, right? So let's replace that. We'd have 52 plus 11 equals 63. That is a true statement, so that means that this equation, or this solution, is correct. For example number 2, notice that 7 is being subtracted from x. So the inverse operation of subtracting 7 would be adding 7. So we're going to add 7 to both sides. Make sure you do the same thing to both sides so your equality remains true. And then subtracting 7 and adding 7 cancel each other out. So that means x remains on the left and we get 38 on the right. Let's check that solution. See the x, we're going to replace it with 38. And let's see if it makes a true statement. So 38 minus 7 is equal to 31. Whoops, equal to, let me find my eraser, equal to 31. That is a true statement. So therefore, this solution is correct. In example number 3, we can see this time x is being divided by 3. This fraction bar means division, okay? So when you see a fraction, what that is representing is a numerator being divided by a denominator. So the inverse of dividing by 3 is multiplying by 3. So I'm going to use a dot for multiplication. Remember, in algebra we use a dot for multiplication so you don't mix it up with the variable x. We're going to multiply both sides by 3, okay? And we can see that if multiplying by 3 and dividing by 3 cancel each other out, so that leaves x by itself, and we get x equals 21. Now, let's go back to our original equation. I'm going to rewrite that original equation. It was x divided by 3 is equal to 7. Let's replace the x with 21, and let's see if that makes a true statement. 21 divided by 3 is equal to 7. That is true, so that means that this solution is correct. And now in example number 4, we can see that x is being multiplied by 4. The inverse of multiplying by 4 is dividing by 4. So I'm going to divide both sides by 4. Remember that fraction bar means division. So if I draw a fraction bar and put a 4 underneath it, that means I'm dividing by 4. So the 4's are going to cancel. Multiplying by 4 and dividing by 4 cancel each other out. So we get x is equal to 5. Okay, let's take our original equation, which was 4x equals 20. Where I see the x, I'm going to replace it with 5 and see if it makes a true statement. And 4 times 5 is equal to 20, so I know that is correct. So x equals 5 is the correct solution. Now in example number 5, we can see that it's going to take us a couple of steps to find our solution for x, because if you look at the variable x, two things are happening to x. X is being multiplied by 6, and then 3 is being added to that. Remember, order of operations would tell us if we knew if we knew the value of x, we would multiply and then we would add, correct? So if we want to undo that, if we want to reverse the process, we need to perform the inverse operations in opposite order. In other words, we want to get rid of this constant term first. 3 is being added to this x term, so the inverse of adding 3 would be subtracting 3. So we're going to subtract 3 from both sides, okay? And then we would get 6x alone on the left is equal to 24. Now look what is happening to x. X is being multiplied by 6. So the inverse of multiplying by 6 would be to divide by 6, okay? And then we would end up with x is equal to 4. So now let's go back to our original equation where we see an x. We're going to put this 4 in and see if it makes a true statement. So let's see, I'm going to get a different color here. So I'm going to take 6 times instead of x, 6 times 4 plus 3. Is that equal to 27? Well, 6 times 4 is 24, and 24 plus 3 more is equal to 27. That is correct. So we know that x equals 4 is the correct solution. Sometimes when we're solving equations, there's some simplifying that has to happen before we can start performing inverse operations. So on this example, notice that there's some parentheses here. The 3 right next to the parentheses, remember, means multiplication. So what we're going to do is we're going to use a property called it's called the distributive property. We're going to take this 3 and multiply it by everything on the inside. Distributing something means you're passing it out. So we're passing out this multiplication to everything on the inside of the parentheses. That will get rid of those parentheses. So then we would have 3x minus 6 on the left is equal to 15. Okay, now that both sides are simplified, now we can start undoing the process of what's happening to x. X has been multiplied by 3, and then 6 has been taken away from that. So we want to undo that in reverse order. So the first thing we'll do is we'll undo that subtraction of 6 by adding 6 to both sides. And when we do, the 6's cancel, and we get 3x is equal to 21. Now we see that x is being multiplied by 3, so the inverse of multiplying by 3 would be to divide by 3. And when we do that, we get x is equal to 7. Now, let's make sure that that's the correct answer. So I'm going to go back to the original equation where I see this x. I'm going to replace it with 7. All right? So we would have, let me just rewrite the equation. It would be 3 times 7 minus 2 is equal to 15. Well, now let's do what's inside the parentheses first. 7 minus 2 is 5, and 3 times 5 is 15. So we know that we have the correct solution. And then I wanted to do one more example with you today, and that is an example like this where you see that there's an x term on both sides of the equation, okay? Now, when you get to this point in solving equations, you have the left side is simplified, the right side is simplified. This is simplified because these are unlike terms and these two are unlike terms, so there's no more simplifying that can be done. But what we want to do at this point is get down to one variable on one side. Some students might be tempted to add 3 to both sides or subtract 13 from both sides, and there's nothing incorrect about that. However, my recommendation is, instead of worrying with the constants, let's get down to one variable on one side. So make a choice of either eliminating 7x from both sides or eliminating a 5x from both sides. I'm going to choose to eliminate 5x only because it'll keep my x term positive. So I'm going to subtract 5x from both sides. Now notice I'm subtracting x terms from x terms. Make sure that you are subtracting a like term from a like term. So on the left, 7x minus 5x is 2x. We would get 2x minus 3 on the left. On the right, these 5x's cancel, and we just get 13. So now we have a two-step equation to solve for x. So x is being multiplied by 2, and then 3 is being subtracted from that. So let's undo that in reverse order. So let's start by undoing this subtraction by 3 to isolate the x term. So we'll do that by adding 3 to both sides. All right, and when we do, we get 2x on the left is equal to 16. And then now, since x is being multiplied by 2, to undo that multiplication, we will divide both sides by 2, and we get x is equal to 8. Okay, let's check that solution. Let's go back to the original equation. Everywhere I see an x, I'm going to put an 8 in there and see if it makes a true statement. So let's see, that would be 7 times, I'm just checking now, that would be 7 times 8 minus 3. Let's see if that's equal to 5 times 8 plus 13. Well, let's see, on the left, 7 times 8 is 56, and 56 minus 3 is 53. On the right, 5 times 8 is 40, and 40 plus 13 is also 53. We get 53 equals 53. That's a true statement, so that means that our solution is correct.